Good morning. Today we will discuss about single phase AC circuits, and we will try to derive the expressions for impedance of network elements. In the last lecture, we have gone through numerical problems on determining the RMS and average values of AC signals. In the last entire week, we have tried these things for different AC signals, namely the trapezoidal signal, sawtooth signal, pulse, square, rectangular, sinusoidal signal, and half wave rectified signal, and also full wave rectified signal. I hope you are now well acquainted with the problems of RMS and average values. And in today's class, we will see the basic properties of the network elements and how they behave in AC circuits. I hope that by the end of this lecture, you will be able to describe the behavior of network elements in AC circuits and also determine the impedance offered by the network elements and also the response to the AC supply. So I will start with the introduction to impedance, what actually is impedance, and then we will see the response of the resistor, inductor and capacitor in AC circuits, and then we will see the numerical problems and then we will move on to the numerical problems, and finally we will conclude upon the basic equations to determine the impedance of the network elements. So let me start with the impedance, what actually is the impedance, and then we will move on to the response of network elements. So what actually is the impedance? So far in the very first 2 units, you have listened only about resistance, even though I taught you the concept of 3 basic elements. We call them as resistor, inductor and capacitor, or their properties: resistance, inductance and capacitance. But we have confined ourselves only to resistances in the very first 2 units because we have been dealing only with DC circuits. And we have defined resistance as the opposition to the flow of current. Whereas in AC circuits also, we will be having opposition from these network elements to the flow of currents. And the opposition to the flow of AC currents is called as impedance. So impedance is normally defined as the total opposition to the flow of alternating currents in an electric circuit. So impedance is the total opposition to the flow of currents. Now we do have the 3 basic elements R, L and C. All the 3 elements, they oppose the flow of currents. Some they will directly oppose the flow of current, some they will indirectly oppose the flow of currents. So in today's class we will see how they oppose or how to mathematically represent their opposition to the flow of AC currents. And now we will discuss about impedance only. So impedance is defined as the total opposition to the flow of AC currents, and impedance is a complex quantity. It consists of 2 components, namely resistance and reactance. Try to remember this one. It impedance is a combination of resistance and also reactance. It is often represented by the symbol Z and is measured in ohms. And impedance is a vector quantity, so it will be just like having a magnitude and also a phase angle. And as already said, there are two components in impedance. One is a resistance and the other one is a reactance. That I will show you now. But before going for that, let me say you one thing, which I have already told you before the start of this course. 3 elements in AC circuits. Resistance opposes the flow of current. Inductance, it opposes change in current. Only when there is a change in current it opposes. And in DC circuits there is no change in current with respect to time unless you vary it. So that's why I haven't discussed this inductance in DC circuits. Whereas in AC circuits, you will be having the signal varying with respect to time all the way. So in this case, this change in magnitude with respect to time can be opposed by this inductance. Okay. Whereas capacitance, it opposes the voltage drop across it, dV. Try to remember these things. Go through the unit number 1, lecture number 1. You will get a quick glimpse of all these things which we have discussed. So R opposes current directly. Inductance, it opposes change in current. Capacitance opposes change in voltage. Since these oppose only changes, I haven't discussed them in unit number 1 in DC circuits. And this opposition is called as reactance. Okay. So reactance is offered by inductance and also capacitance. And it depends upon how much there is a change. That we will see in the next slide. Okay. So, as already said, impedance consists of two parts. One is resistance, the other one is reactance. Okay. The units of impedance is ohms, resistance is also ohms, and reactance is also ohms. And for impedance, the symbol is Z, and for resistance it is R, and for reactance it is X. As already said, there can be two types of reactances. One is inductive, the other one is a capacitive, right? So if it is offered by inductive, it is called as inductive reactance. If it is offered by capacitance, it is called as capacitive reactance. Okay. So now confining ourselves only to resistance. Resistance is represented by the symbol R. It represents the real part of impedance. As already said in the previous slide, impedance is a complex number. Okay, it will be having a real part and also imaginary part. Real part is the resistance and imaginary part is the reactance. Okay, so resistance represents a real part of impedance. It is due to the opposition of flow of current in a circuit due to the resistance. And this resistance in a circuit, you can have so many elements, each element can be offering resistance. So the net resistance is represented by R. And the resistor, it dissipates power in the form of heat. Try to remember, resistance doesn't store energy. Doesn't store energy. It only dissipates power in the form of heat. And it is not affected by the frequency. Whether there is a change in current or change in voltage, it doesn't bother. It just opposes the flow of current. So that's why resistance is not affected by the frequency of signal at AUG level. Okay, and it is measured in ohms, as already I said here. Okay, so quick glance. Resistance represents a real part of impedance. It is caused by the opposition to the flow of current offered by different network elements, and it doesn't store energy. It dissipates power in the form of heat, and it is not affected by the frequency of the signal. Okay. Now moving on to reactance. Reactance is an imaginary component of the impedance. Okay. It can be due to either capacitance, we call it as capacitive reactance XC, or it can be due to inductance. We call it as inductive reactance. And both of these XL and XC, they vary with the frequency of the AC signal. And X is measured in terms of ohms. Okay, and I will write down this equation here, but I will explain it in the last slides of this lecture. Capacitive reactance is inversely proportional to frequency. See, reactance is represented by X. It consists of 2 times XL and XC. This is directly proportional to frequency, whereas this is inversely proportional to frequency. And the units are ohms. Try to remember these things. Okay. So, as a whole now, impedance is a combination of 2 parts, a real part and an imaginary part. Real part is R, imaginary part is X. So if I represent it in complex form, Z is equal to R plus Jx, where R is the resistance and X is the reactance, where J is the imaginary unit. Okay, and this reactance, it can be of XL and XC. So I'll take it as XL minus XC, where this is inductive reactance and this is capacitive reactance. Okay, hope you have understood these things. Now, in the next video, I will tell you about the behavior of resistor, inductor and capacitor in AC circuits. Okay, so I will close this video and I'll start this response of these elements in AC circuits in the next video.